dengan Islam sejahtera. My name is Muhammad ISMAIL and I'm from class 2 BINTI.
Assalamualaikum. My name is AZIMAH binti AZMAN with matrix number B0920100216. I am from class of BMMH S1 S1.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya MUHAMAD IMRAN bin RIZAL dari kelas 2 BMH section 111.
Assalamualaikum warahmatullahi wabarakatuh. My name is FATINI. My matrix number is B0920100107.
Okay, first open the water supply.
Dia also
Wait
Then change the flow rate and change
Wait until it is 60 degrees Celsius. To the counter flow. Yeah.
Okay.
Let's start.
Okay. Then start balik Bismillah.
So, for the objective are to show how different cold flow rates affect the performance of the heat exchanger in both parallel flow and counter flow connection, which is hot flow rate and heater temperature are fixed. To analyze the result gain from parallel flow and counter flow and discuss the reason for different result for both flow to determine which flow gives the best heat transfer rate. Introduction. For most heater transfer equation and calculation of specific heat capacity and density of water, it must find the average temperature for the hot and cold circuit in the heat exchanger. The equipment that we use for this lab is base unit, concentric tube heat exchanger and plate heat exchanger. From the experiment, we can get the data for counter flow and parallel flow. For the test 1, 2, 3 and 4, by using the same heat flow, which is 3, so we can get the cool flow and all the data for the result. So this is also the data for the result from the experiment for the previous slide,
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is MUHAMAD IMRAN. Now we continue this discussion for this presentation. So number 1, as you can see, this is a chart which is temperature profile chart, and this is chart for counter flow. The data is 54.8, 57.5 and 59.8. Blue line 1 and orange line 1 is 25.9, 28.8 and 30.8. Next is parallel flow. The blue line is 53.6, 56.1 and 58. The orange one is 26.6, 28.9 and 31.
Welcome and selamat sejahtera. My name is Muhammad ISMAIL and my metric number is B09201026. So next for the discussion, based on information in the result table, create a chart of energy balance, coefficient vertical axis against heater temperature, horizontal axis. So firstly, we must find the energy balance coefficient by using this formula, CEB equal to QA over QE, which is mass heat transfer for inlet and outlet. So this is the result we get. Next is the bar chart that we made for parallel flow and counter flow. So for the next discussion, find the LMTD and use this to calculate heat transfer coefficient for each heater temperature. Comment on how the heater temperature affects the heat exchanger performance. So first, we must calculate the LMTD using LMTD formula. TH2 minus TC2 minus TH1 minus TC1 over ln TH2 minus TC2 over TH1 minus TC1.
So here is the value of U for parallel flow. The formula is QE over A times with LMTD. For U1 for parallel flow is 0 and U2 is 14951.44 and U3 is 17832.12 and U4 is 17532.92. After that, for the counter flow, the U1 that we got is 27162.38 and U2 is 24878.25 and U3 is 19856.06 and for U4 is 16735.40. So here is the comparison between the heat transfer coefficient for the parallel flow and counter flow. So the counter flow have the greater value of heat transfer coefficient than the parallel flow. Thus, counter flow is the best heat exchanger. In a conclusion, we have learned on how to determine the performance test and calculate the LMTD and effectiveness of heat exchanger in parallel and counter flow. Other than that, we have also learned to establish which flow gives the best heat transfer rate, which are counter flow, where the counter flow heat exchangers are more efficient than the parallel flow. This is because the uniform temperature difference between fluids to the whole exchanger and fluid path. We also learn to calculate the coefficient, efficiency, specific heat capacity and density and analyze the results for parallel and counter flow. And lastly, we acquire that counter flow have the best heat transfer rate than the parallel flow.